Hello and welcome. Today is 4th of December and this is the CBSE Class 10 Daily Math video. We are discussing real numbers and today we are going to take a look at this particular type of question that can actually come in your board exams. Show any positive odd integer is of the form 8q plus 1, 8q plus 3, 8q plus 5 and 8q plus 7 where q is any integer. Now in the final exams, you may not get 8q plus 1, but you may get 6q plus 1 or 4q plus 1 or 2q plus 1. But in this video, we are going to explore how do we approach these type of problems. So let's get started. Now it's important to recognize that these type of questions typically will carry about 2 marks in your final exams. Now, so let's find out how are we going to solve this problem. Well, first thing to recognize is these type of problems we have to use Euclid's division lemma. So these are applications of Euclid's division lemma. So what we are going to do is we are going to say, let us assume that a is any positive odd integer. And then what we are going to do, we are going to divide a by 8. Now why 8? This denominator, the reason this is 8 is because in the question we have been asked 8q plus 1, 8q plus 3, 8q plus 5, 8q plus 7. If this were 6, 6, 6, 6, we would have divided a by 6. If this were 4 or 2, we would have used that number to divide a by. Now, so what happens when we divide a? We divide a by 8. Well, Euclid's division lemma says that whenever we do any division, we typically will get a quotient and we get a remainder. And we will be able to write the number a, I should say the number a here, number a as 8 times quotient plus remainder. And q can be any integer, but when it comes to r actually can be 0 or greater than 0, but r must be less than 8. So that is, the remainder must be less than the divisor. We know this from Euclid's division lemma. I'm going to provide the link for Euclid's division lemma in the description box below. So what are possible values of r? That means r can be 0, r can be 1, it can be 2, it can be 3, it can be 4, 5, 6, 7, it cannot be 8 because r has to be less than 8. So let's do one thing. So in this equation, a equals 8q plus r. Let's put each of the values and see what happens. So let's write over here. So a equals 8q plus, when r is 0, we write this is 0. Then we have a equals 8q plus 1. A equals 8q plus 2. A equals 8q plus 3. So we have written 0, 1, 2 and 3. Now let's write a equals 8q plus 4, a equals 8q plus 5, a equals 8q plus 6, and finally a equals 8q plus 7. So these are all the values for a. Now one thing to closely look here is that q can be any integer, right? But what can we say about 8q? Meaning 8q is simply 8 times q. So what happens if we take some positive odd integers for q? Let's say if q is 1, what do we get? So 8q will become 8 times 1, which is again 8. That means if q is odd, 8q is even. What happens if q is even number, which is 2? So then 8q will be simply 8 times 2, which is 16. In other words, regardless of whether q is even or odd, 8q is always going to be an even number. Now remember what we started off with. We assumed a to be a positive odd integer. So let's take a look at these 8 expressions and see which one will give us a as a positive odd integer. 8q is even, so 8q cannot be equal to a, so this does not work. 8q is even number plus odd number is odd, so this will be true. Similarly, 8q plus 2 is even, that cannot be odd, so this will not work. The next one will work. 8q plus 4 is even, that cannot be odd, so this doesn't work. 8q plus 5, even number plus odd number is an odd number. This works. Similarly, this will not work, but this will work. So let's clear this up. So what we will get is that we get A equals 8q plus 1, A equals 8q plus 3, A equals 8q plus 5, and A equals 8q plus 7. So A is any positive odd number, and we see that we can express A in this form. So this is how we answer these types of problems.